Given that x is secant squared of 2y, where y lies in the range 0 to pi over 4, show that dy by dx is the given expression. How can we solve this problem? Let's have a look. We need dy by dx, but the equation we have is x in terms of y. Do we need to convert it to y in terms of x? In other words, do we need to solve for y first and then take the derivative? In truth, we don't. We can actually find dx by dy and then take the reciprocal. To differentiate secant squared, we'll bring the power down and subtract the power by 1, your typical power rule for differentiation. So that will give us 2 secant 2y, and then we have to use the chain rule to multiply by the derivative of secant 2y with respect to y. The derivative of secant is secant tangent, so this will be secant 2y tangent 2y. But again, we have to account for the chain rule and multiply by the derivative of 2y. But that's just 2. So we have 2 secant 2y tan 2y, and we can substitute that in the equation for dx by dy. 2 times 2 is 4. We have 2 secant 2y copies, so that will be secant squared of 2y. And now let's invert this to get dy by dx is the reciprocal of 4 secant squared 2y tan 2y. So this is dy by dx, but notice that we have it in terms of y, not x, and we want to express this in terms of x. So we need to convert secant squared of 2y to something involving x only, and the same thing for this tan 2y over here. X is given to be secant squared of 2y, so we can simply replace this term by x. But how about the tan 2y? Is there a relationship between tan and secant? Yes, we know the trigonometric identity tan squared theta plus 1 equals secant squared theta. In this case, theta is 2y, and we can solve for tan by taking 1 to the other side and then taking the positive square root. Notice that we know tan is positive because of the range of y given, so I did not care about the negative square root here. Secant squared 2y is x, so we can plug that back in and we get dy by dx is 1 over 4x times the square root of x minus 1, hence proven.